The Earth's atmosphere is made up of different layers containing progressively fewer atoms of gases with height above the Earth. From a height of about 50 kilometers up to 400 kilometers, the atmosphere is also designated as the ionosphere, because ionization takes place there. It is divided into 3 layers, D, E, and F. Ionization is the process by which negatively charged electrons are dislodged from the outer shells of an atom by ultraviolet light from the sun, leaving the atom with an imbalance of positive ions. When gas is in this state, it is known as plasma. The extent of the ionization is such as to create bands of negatively charged electrons, and it is these bands, or layers, which refract radio waves. Ultraviolet light waves of different frequencies penetrate the atmosphere to a different extent, creating bands of ionized gases at different levels. Because ionization is dependent upon the sun's energy, it is greater during the day than at night. When a radio wave is transmitted into an ionized layer and it returns, it is called a sky wave. The refraction or bending of the wave occurs because there is an abrupt change in the velocity of the upper part of the radio wave as it strikes this new medium of plasma. The ionosphere layers are less dense, with electrons at their outer edges, so it is at the center of these bands that the greatest refraction occurs. Radio waves do not always refract and return to Earth somewhere. The angle at which the aerial points is critical. If the wave is transmitted vertically, it may pass straight through the ionosphere and out to space. By increasing the angle from the vertical, an angle is reached called the critical angle when refraction occurs, and this is called the first returning sky wave. But there will be many returning sky waves because radio waves fan out from the transmitter and they will reach the ionosphere at different places, and therefore they will return to Earth in different places. The distance from the transmitter to the point where the first returning wave comes back to Earth is called the skip distance. There is one other term that has to be known, and that is dead space. We have seen that surface waves will only travel out as far as the point where they become so attenuated that they can no longer be detected. The distance from this point to the skip distance is called dead space because no transmission is being received there. We know that the density of free electrons in the ionosphere varies. At a given frequency, as ionization increases, the critical angle for transmission can be less, and this has the effect of reducing the skip distance. And as the surface wave distance remains the same, the dead space will reduce. When ionization decreases, the critical angle will be greater, the skip distance will be greater, and so will be the dead space. By a simple application of the angles of incidence and reflection, we can also see that skip distance increases when the radio wave is refracted from higher up the ionosphere, such as from layer F1 rather than layer D. Another relevant factor in the refraction of radio waves is the frequency of the radio wave. Because the degree of ionization varies with solar activity, the time of day, and the angle of the sun, the ionized layers vary in their ability to refract radio waves. The highest frequency wave that can be refracted for a given range is known as the critical frequency. Any transmission above this critical frequency will not be refracted, as the radio wave has too much energy for the level of electrons in the layer, and it will pass through the layer. As frequency increases, the critical angle will increase, and the skip distance and dead space will also increase. When refraction does occur, the radio wave may reflect back up to the ionosphere in what is called multi-hop propagation, and this can result in transmissions going halfway round the world. The maximum range for sky waves will be achieved when the path of the radio wave is tangential to the surface of the Earth at both the transmitter and the receiver. However, maximum range may not always be the criterion. Perhaps a stronger signal or a closer recipient may be required.